Kilo 4 Romeo Romeo.
Romeo, Romeo station, come back slowly and repeat your call sign in FTDX.
Thank you, sir. The call sign here is Kilo 4 Romeo Romeo KK4RR, and my name is Rick, Romeo India Charlie King. QSL?
Roger, Rick, and where are you located, sir?
I am in High Point, North Carolina, in the central part of the state.
Roger that. And what radio are you running today, sir?
Roger that. And what radio are you running today, sir? I'm running a new radio to me and a new Heil radio headset, Pro 7 QSL.
Okay, your headset is Pro 7?
That's correct.
And what's the radio?
Yaesu FTDX-101.
Roger that. Just slipped down on my local antenna now. I've got a copy on you for a little bit there. If you're interested in our setup, it starts with double checking to be sure you're in that wide transmit bandwidth. 100 to 2900 is what we're talking about there. You let your transmitter be all that it can be, and then at the last moment gives you a slice of daylight before you're into somebody else's conversation. Roger?
Roger, roger.
So, if you check, you're probably in that transmit mode already, but if you're not, it can restrict your top end. If you're down to 27, transmit bandwidth, you're missing, a little bit more of the top end that just got rolled off because you're not in the best transmit bandwidth, Roger?
Roger, I believe that I'm in 2900. I don't recall what my lower end is. It may be 200. Go ahead.
Roger, you seem to be rolled a little bit on the bottom end, but it's still very intelligible, and I'm not a proponent of a bunch of bottom end anyway, because there's a lot of things that can happen to your transmission as it sallies forth into the atmosphere, into, towards somebody else's location. One of them mainly being reflected from two different points in the ionosphere and coming back, one slightly out of phase with the other, and then you have a thing called cancellation. And phase cancellation always starts at the top of the audio spectrum and works its way down. So the first thing that you lose when you have a situation of phase cancellation, you lose the top end. So if you had a well-balanced signal with a lot of bottom and a lot of mids and a lot of tops, well, the first thing that goes there is all of that top end information, and you could become Mr. Mumbles. So because of that, I don't really espouse a bunch of bottom end unless one happens to be particularly fond of that. And of course, everybody needs to chart their own boat. Roger?
Roger. And indeed, I've just checked my radio settings, and my TX BPF is listed as 100 to 2900, so I think that I'm within the parameters that you recommend. I have turned on my processor, and I'm going to turn it off now. Here we go. Now it's processor off. But please know that I have played with my. Please know that I have played with my equalizer to decrease audio in the lows and boost them in the mid-range and highs. Go ahead.
Okay, so the thing about an equalizer is it's designed to equalize from the top end to the mid-range and the bottom end to the mid-range, so you have a nice curve, whatever, you know. But the point I'm making is that you need to be sure and keep that mid-range flat, because that is, if you boost the mid-range, then it's going to be so much harder for the top and the bottom to catch up equalizer-wise. So we suggest, and we'll do that later on if you want, but that the mid-range stay flat or off. Plus or minus 0 or off for the mid-range, and then it's so much easier to get a balance between the top and the bottom. Roger?
Yes, okay. I guess that I was unaware of that, but I can make that happen. That's an interesting concept. I know that I decreased by lows and increased the mid-range some, and then increased the upper range more so. So I'll take a look at those settings.
Yes, sir. So, theoretically, and I don't know what kind of an equalizer you have. Is it a 3 equalizer, or is it 8, or what have you got for an equalizer?
Or is it 8, or what have you got for an equalizer?
On this range, it is a 3-range equalizer, and can choose. Let me get to the bottom here. So you can choose this equalizer 1, 2, and 3, and I've chosen the equalizer frequency to be 300 hertz to start, and then there's a bandwidth which I don't quite understand, but the bandwidth on this runs from 0 to 5, and in most of the books I've read that you should use the 5 or mid-range of that bandwidth. I have my parametric equalizer in the 300 hertz range set to minus 15, which is a significant cutoff. And then for the mid-range, which begins at 900 and has a bandwidth of 10, which is the maximum, I have a 10 dB increase. And I do the same at 2200 hertz. So perhaps I need to reduce my equalizer level in the mid-range from a 10 dB boost down to near 0. Is that your suggestion?
Yes, sir. The thing is, mid-range EQ is so harsh. It's a very harsh frequency, and when pushed, it becomes even harsher. So that's why we suggest, intelligibility is in the upper mids of the range as far as frequency response is concerned. So I'll give you this. If we make that mid-range control flat, plus or minus 0, or off, that would be the beginning. Mid-range plus or minus 0 or off. Roger?
Mid-range plus or minus 0 or off. Roger?
Okay, so what I've done now is I have, let me go back to it, I have decreased the amount of lows that I've cut off from 15 dB down to 10 dB down. My mid-range at plus or minus 900 hertz is flat, and my upper frequency is beginning at 2200 plus or minus is plus 10 dB. Do you like this any better?
Yeah, but the top end, the ideal push frequency for that treble is 2700. 2700 is the ideal push frequency on that. If you can adjust that frequency to 2700, that would be great, Roger.
To 2700, that would be great, Roger.
Okay, I've just done so. Now I'm at 2700, and the push frequency for mid-range, I have it set for 900. Would you leave it there?
No, see, the mid-range is out, flat, off. It doesn't matter what frequency it is because it's out of the circuit. It is plus or minus 0 or turned off. Roger?
The circuit. It is plus or minus 0 or turned off. Roger?
Well, on this radio, I'm obligated to put in a frequency and then an equalizer level and a bandwidth that is it's plus or minus that frequency. So it's going to be the mid-range, would you define as 900 hertz plus or minus?
Right, yeah. But so why don't you put plus 0.5 on your mid-range control, you know? If you have to have it in and you can't turn it off, just make it 0.5 push. Very small, half a dB push, just to have it in the circuit if it has to be, Roger?
Just to have it in the circuit if it has to be, Roger?
Okay, so this is just 1 dB. There's no ability for me to make it a half a dB.
All right, so make it a negative, 1 dB negative on your mid-range control.
Mid-range control.
Okay, we are now -1, and I thank you so much for taking the time to do this, sir.
Yes, sir. Okay, now go to your treble. The frequency is 2700, and width of 4. If you have the width shaping, we want that width of 4. Frequency is 2700, and we want to go. What's your current level on that treble boost?
What's your current level on that treble boost?
Let's see. My current level is. My current level is 5. Let me make it 5. Current level for 2700 is 5, and the bandwidth is 5. Go ahead.
Okay, make the bandwidth 4, width of 4, 2700 the frequency to push, and what is your top end push level on that 2700?
What is your top end push level on that 2700?
When you say top end push, what do you mean, sir?
Yeah, how far can you advance the treble control? If you're at 5 now, can you go to 10, 15, 20? What's your max on your treble boost?
Go to 10, 15, 20. What's your max treble boost?
Okay, one moment. I'll take a look. The max, my max is 10. My max is 10 for the frequency range in the 2700 area.
Roger that. So, and right now you're about a 5?
Roger that. So, right now you're about a 5?
Yes, sir.
All right, come on up a couple of more clicks to a 7, plus 2 clicks additional from where you are, plus 7 on that 2700 treble equalizer.
On that 2700 treble equalizer.
Okay, now I am on click 7, so 7 dB gain at 2700 hertz plus or minus.
Okay, so then let's go to the bottom end. I want you to set the frequency for 200. I want you to set the frequency for 200. Roger, Roger.
200. I want you to set the frequency for 200. Roger, Roger.
And we'll go flat on the bottom end, but your frequency, operable frequency is 200, and again a width of 4, frequency 200, and right now it'll be a flat, and we'll roll that off. Roger, as we go.
Now it'll be a flat, and we'll roll that off. Roger, as we go.
Okay, so I am frequency 200, a width of 4, and I'm down 10 dB. That's where I'm starting. Go ahead.
You're minus 10 from flat, minus 10 down from flat?
You're minus 10 from flat, you're minus 10 down from flat?
That's correct.
Gosh, sounds pretty good. Tell me about your radio and the best thing you like about it.
Pretty good. Tell me about your radio and the best thing you like about it.
It has a marvelous receiver, very, very quiet, and any noise canceling aids that allow it to make signals very intelligible for me. My previous receiver was an Elecraft K3, which is a very fine radio, but its noise reduction does not compare to this Yaesu. I love this receiver very, very much. Go ahead.
Roger, Roger. So just for kicks, why don't we bring that bass up to -5, just to see. I think you're right at -10, but let's hear what it sounds like at -5. So come from -10 up to -5, so you're not attenuating, you're only attenuating half of what you were the other way, Roger?
You're only attenuating half of what you were the other way, Roger?
Okay, here we go. So now I'm at -5 at 200 hertz with a width of 4, and it's -5. My previous transmission was at -10.
Yes, sir. I would run it just like that. You're fuller in the bottom end. You're less harsh, and still your articulation level is the same. It's just beautiful. And if you want to hear that radio, if you go to YouTube and do a call letter search for Kilo Charlie 9 Victor Kilo Victor, followed by the word logbook, that will take you to this recording. It'll be cut number 1 in a series of 3,500, and I'll have it uploaded to YouTube by noon tomorrow, Roger.
And I'll have it uploaded to YouTube by noon tomorrow, Roger.
Well, I am very, very grateful, my friend, for you doing this. This is a fabulous service. Your experience with audio is just incomparable, and I so greatly respect it. Before you go, I have one question, and it is not explained in the Yaesu operating manual, nor in any of many other literature I can find. But the bandwidth, which has generally from 0 to 10, what is that bandwidth? Is that in hertz or kilohertz or some other denomination?
Well, it's decibels, dB, and it starts with somebody, unprocessed audio has what's called a 10 dB dynamic range. That is, if I were to have a VU meter tied to a PA system that you were talking on at a baseball game or something, that meter would be bouncing all over the place from 0 peak back to -10, and we would call that a 10 dB dynamic range. Okay, so but the problem is that that's not fat enough to be a signal that would be well received on amateur radio. We want to fatten that signal up, so we go from a 10 dB unprocessed signal with a 30% of peak modulation to a higher 3 dB dynamic range with an average percent of peak modulation somewhere around 80 to 85%. And it becomes a much better signal to transmit because it's so full, and you get into marginal situations, you want a full sound to be able to be heard, Roger?
Situations you want a full sound to be able to heard, Roger?
Okay. I understand that. Of course, so there is, going back to the operation setting, there is I understand the equalizer setting for how many dB you wish to push a particular range of frequencies. So I understand that it can be plus or minus 5, 10, 15, or 20 dB. But the bandwidth, I'm guessing that is the range of frequencies that this adjustment covers. So if we're talking about a center frequency of 900 in mid-range and have a bandwidth of 5, am I to expect that we're adjusting this range of frequencies plus or minus 500 hertz, or do you think it's something else? I know you don't know this radio quite so well, but can you take a best guess at it?
Well, yes, sir. The transmit bandwidth determines how wide the transmitter transmits as far as up to 3 kc, you know, and that's the allotted frequency range for transmitters. The thing is, though, if you go out to 3 kc, you could start ringing distortion bells and get love beads going up the frequency. Once you get distortion, all bets are off, because distortion has a multitude of different things that it can do simultaneously. So you want to stay out of distortion, and you also want to stay out of somebody else's conversation as much as you can, and they will, you know, probably stay out of yours. So the reason that we pick that 100 to 2900 transmit bandwidth is that it allows your transmitter to transmit up to 2900, then gives you just a slice of daylight in filtering before you're into somebody else's conversation. Roger?
Filtering before you're into somebody else's conversation. Roger?
Perfect. Yes, I understand that fully. Once again, thank you so much. I hope that you can pass this knowledge around to more. This is a great service to me. All the best to you and yours, my friend, KC9VKV. This is KK4RR73.
Roger, Roger, Harry. This is Kilo Charlie 9 Victor, Kilo Victor. And again, if you want to hear that audio, you go to YouTube, do a call letter search for KC9VKV, followed by the word logbook. That will take you to this recording, and I'll have it uploaded by noon tomorrow. So, 73, sir. And if you get a chance, join us next Friday. We'd love to have you. This is the Friday afternoon Qso-Vlog net. If you have a radio you want to check out, give me a shout.